Yeah, I'm the co-founder and CTO of Honeycomb.io. We are kind of the original observability company. We just announced yesterday our Series D, $50 million Series D. So that's pretty exciting. And
Congratulations.
yeah, thanks. Been around since 2016 and starting to really take off.
Okay, cool. So today's topic is observability and everything around that. We have approximately like 40 minutes, so we will try to make the best of it. So let's start with the basics. So why we need observability in the first place? Why we just can't say like, hey, it will run by itself. Like if something bad happens at night, who cares? Like the developer in the morning will get it up. Like no, why the hustle?
Sometimes you can. This is what you need to know your own product and the expectations that your own users have of you, right? But typically in modern systems, your users have higher expectations of you than that. Usually there's a dollar amount associated with being unavailable. And usually that dollar amount and those user expectations are way too important to wait until the morning. Although, you should architect your system so that as many things as possible can be down until morning. But if it's impacting your users, you kind of have an obligation to them to get it back up. And observability in particular, I feel like it's more than just incident response. It's more than just keeping the site up, right? It's about understanding your software and understanding your software systems. And the days of the original split between dev and ops, the days where devs would write the code and then the test would run, and so they'd hand it off and then ops would like run the code. Like those days are gone. Like it's actually impossible in modern complex systems for the person who's running the system to not also know how to build the system. And it's impossible to build systems well unless you're also running those systems. And so, the roles are really converging. Observability is you should be instrumenting your code as you're writing it. You should, deploy it swiftly, small changes frequently, not big bang changes infrequently. And then you should look at it. Your job isn't done as a developer until you've looked at it running in production, and you ask yourself, is it doing what I expected it to do? Are my changes having the desired impact? And does anything else look weird? Right? If you're not following your code all the way through to its ultimate use, then you're not really fully doing your job.
Okay. That sounds insightful. So when we're talking about observability, what do we include in this? Is it just like monitoring and like alerting about something bad happened? Or is it a broader thing than just a couple of practices?
I think it's a very distinct thing, and this is where the waters have gotten a little bit muddied in the marketplace for the last few years, because now everybody claims to be doing observability. But in my world, monitoring is about the known unknowns. Something can fail, so you monitor for it. And observability is about the unknowns. It's about instrumenting your code so that you can ask any questions, so you can understand any state that it might get itself into, even if you can't predict up front that those things might happen.
Do you have any examples of such a things like, I don't know, flood in the data center or?
For sure. So like monitoring is based on the metric, right? And there's like little m metric, which is generic telemetry. And then there's, capital M metric, which is a metric is a single number with some tags appended so you can find it. And most of, the last 20, 30 years of monitoring software is all based on that metric, which they're very cheap, they're very fast, very powerful. You can make dashboards out of them, etc. But they have a really big flaw, which is it's just a number. It's discarded all of the context at write time, and you can never get it back again. Observability is built on arbitrarily wide structured data blobs, which you could also think of as spans, right? They're wide. There's lots of key value pairs. There's lots of stuff, and it's all knit together. One of these wide rows per request per service. And what that allows you to do is slice and dice, ask new questions, combine. So like, for example, let's say that, you're working on a system and you see a spike in errors and you're like, what is that? Well, if you're using observability, you can start at the top, you can slice and dice, and you can figure out like, oh, actually, all the errors in the spike are coming for requests for this particular build ID, for this region of the world, for this app, using this particular language pack, with this variable enabled, just like a chain of all these things, right? If you were using traditional monitoring and metrics, you could only do that if you thought in advance and you're like, I'm going to capture a custom metric for this build ID, this language pack, this region, and just like the the possible permutation of all the things you want to track just becomes insane. You can't predict every single, intersection of every variable that you might care about. Both with observability, when you have those wide rows and you have high cardinality, high dimensionality, and the other things that come with observability, then you can just slice and dice. You can ask any question that you want of your data, and you can find the answer.
Okay,
making
cool.
sense?
So yeah, it makes a lot of sense. Let me do an analogy. So basically, if we're like talking about the health of the system, like we're talking about the health of a person, we can say that classic monitoring is just trying to measure the temperature and I don't know the weight of the patient, and that's it. While observability is like constantly doing an MRI and looking at the whole picture and measuring all the parameters and understanding what's really happening inside the body, inside the system. Is that correct?
Yeah, I would almost liken it to having a scalpel and a scope that's like wandering around inside the body and able to just sense all of these things you didn't even know were there. Like maybe there's a mass there. You didn't even know it was there, so you didn't know to look for it, but you're looking at it up close, so you're able to see it.
Cool. So observability allows us to understand the system very well from inside, right? And to see the whole picture. Yeah, that can be useful. What is the impact of this observability on the business? Like why business cares in the first place?
Well, you care about your users and their experience, right? Like ultimately that's why we're all here. And you care also because the scarcest resource in every tech company is engineering cycles, and the more you have to spend those. There was a Stripe developer report a couple of years ago that showed that like 41% of all developer time is basically wasted. It's spent on tech debt. It's spent trying to find the thing that you're trying to reproduce, or it's spent trying to reproduce the thing that you're trying to find, or you're wandering through all the stuff that you have to do in order to get to the stuff that you want to do. So much of that time is wasted because we can't really see what we're doing because we're doing so much of trying to, there's something that's happening in production. You're trying to figure out what it is. You're reproducing it on your laptop and just like, it isn't there and it isn't there. Like we spend so much time just wasted. So like the business cares obviously about the user's experience. One important difference between monitoring and observability, again, is that monitoring is centered on the system. Is the system healthy, right? Do I need to add more capacity? Do I need to add more disk space? Is the RAM or CPU spiking? Observability is centered around the user. Like the user is the original high cardinality value. Like, and when I say high cardinality, in case people aren't clear, it's like, imagine you have a collection of 100 million users. The highest possible cardinality will be any unique value, like social security number. And the lowest possible cardinality is anything like with one value, right? Because it's the number of unique items in the set. So like species equals human, very low cardinality. Monitoring and metrics tools are great at low cardinality dimensions. But when it comes to understanding your systems, the high cardinality values are always the most revealing ones, right? Like unique ID or the build ID or the request ID or the span ID. Like when you can get those very fine, sorry, I'm going way off trail. The business cares about users' experience, but it also should care about engineers' ability to do their jobs efficiently and effectively. And observability is really critical to both.
Okay, so it's basically not only about users, but about users majorly, but also about the developers.
It's also about the developers, and it's like, yes, from a financial perspective, you want them to spend most of their time moving the business forward, not floundering, but also it's like a quality of life issue. It's so no one ever got burned out from shipping too much code. You get burned out from just like, flailing and just like kind of bouncing your head against the same problem like for way too long and not making any progress. And a lot of that comes down to just not being able to see where you're going.
Okay, yeah, I never thought about this that way, but yeah, I will start soon. Okay, cool. Thank you very much. Let's continue. So we're talking observability, blah, 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 and comparing with just monitoring some metrics. But what is the state of the art of observability nowadays? What tools and practices it includes nowadays in modern systems?
Well, obviously I'm a vendor, so but but like my opinion here predated my company, and I still think it has a lot of value, which is that you can't have observability unless you have high cardinality, high dimensionality, and the ability to trace. And I would say that Honeycomb and Lightstep are the only vendors out there that have what I call an actual observability solution. But I know that other vendors are racing to catch up, and I'm sure that they will. I mean, it is the right way to do. The traditional way that people have been trying to solve this is by throwing product after product at it. So like, your Datadogs or SignalFx, they'll have like a product for dashboards and monitoring, a product for logs, a product for tracing. And this is where that whole thing about the 3 pillars of three pillars are bullshit. It's just different data types. And the more you like balkanize these things, the harder it is to stitch them together. Imagine, like you're looking at your dashboard, you see a spike. You're like, errors, I care about these. So you go to your logs and there's nothing that connects them. You're literally just like trying to match timestamps, and you're guessing that these log lines correspond to or correlate to this spike over here. There's nothing that connects them but you. And then if you want to trace that thing, you have to copy a trace ID from your logs and hope that it got captured into your trace tool, and then trace. Like there's nothing. That's not observability, if you ask me. That's monitoring. That's like asking the human to sit in the middle and be the only connective tissue. When you've got when you've got real observability, that wide event is the source of truth. You can derive metrics and dashboards from it. You can derive logs from it. You can derive traces from it. And so the experience is more like, okay, I see a spike in my dashboard. Okay, these are the events in that spike. Okay, I'm going to trace one of those events. And you can just move back and forth seamlessly. And it's just a much better experience.
So you're saying modern observability should be a connected experience centered
Yes.
about the system itself, and the ability to look through it transparently and seeing like actually what's happening, and not doing this job of connecting the dots all manually.
Yeah.
Okay, cool. Yeah. I would imagine that would be an amazing.
Transformational. It's frustrating because, all of us are out here, we're using basically the same words to describe our tools because there's only so many terms in data. But like having the experience of a real observability tool is profoundly different. Like our hardest problem is like getting people to try us with their data. Once they've tried, like we have zero churn. We are the only vendor in the recent survey where people said they planned on spending more because it actually worked. It's really hard to convey to people just the power of the difference between real observability and everything else out there.
Yeah, so it really sounds like a revolution to the developer experience in the first place, and being able to resolve an issue in like a matter of 15 minutes instead of like hours.
Oh, seconds.
Seconds. Okay.
We often have this thing happen where, our sales engineers will be helping roll out, roll Honeycomb out internally, and they'll start going, oh, what's this? Or are you having an outage? Or did you know that this was broken? And they'll just be like, how did you find that? It's just right there. But unless you have the tooling that lets you see it, it's basically invisible because you don't know to go look for it unless you can see it.
Okay, cool. But now I wonder, how it should work. So is it like some kind of a tool that instruments the code itself and just gathers the data and provide the systems to visualize it, or it works in some different fashion?
Well, the way that the instrumentation side works under the covers is, a request enters a service. We initialize an empty event. We populate it with everything, like any parameters that were passed in, whatever. We automatically wrap like any HTTP calls, any database calls, etc. And then you can just stuff in like anything that you would have captured for a custom metric, anything that you would have put in the log, you just stuff it into the event. And then when the request is ready to exit that service, exit or error, it ships it off to Honeycomb in one arbitrarily wide structured data blob. Now, all of this we're all in at open telemetry. So we're huge like proponents of like shift. Open telemetry should be the last best migration you should ever have to do for your telemetry because all the vendors support it. And the idea behind OTel is you instrument your code using open telemetry, and you can move from vendor to vendor without having to re-instrument your code, which makes vendors compete for your business based on how good they are, not based on you being locked in. So side pitch for OTel over. a lot of this can be done under the hood. So you don't have to think about, packaging it up, but that's how it works. You just have to think about, here's something I want to put in the event, stash that, stash that, stash that. And then when it gets shipped off to us, the magic under the hood is that we have a custom built columnar store. So, so you don't have to worry about like creating an index, or is this query going to be fast or not? Like everything is fast. Like our 95th percentile for query speeds should be like under 5 seconds. So it's really fast. And that means that you can just dump anything in that you want, and then, immediately start slicing and dicing. Does that answer your question?
Yeah, I think it is mostly. The only concern I have at this point is like, how does it work? So the solution itself should be something installing into the perimeter of the company, right? It's like inside their cloud or on their premises.
Right. So you want to instrument your code, and that can be either a little sidecar app, or you can just install the library into your code itself.
Yeah, but the rest of the solution, so all this, monitoring dashboards, the tracing tools, everything else. So it's still, is it like in your cloud, or it should be on the client?
Oh, it's a SaaS. Side? Yeah, you send it off premises to us. Yeah. Mm-hmm.
Yeah. Okay. So once we figured that out, my concern will be still valid. So what's about the privacy? It's like, basically, as a client, you're exposing your soft underbelly to you. So it's like kind of like we're giving you information about everything we do.
Well, there are a lot of like we can find like the HIPAA stuff and everything. But like what we have is something called secure proxy, where you can install this proxy inside your premises. Sorry about the noise. And you stream your events through it. It captures, it takes a mapping of the raw event to the fingerprint or the hash value, forwards the hash values to us. We store the hash values. We never get the unencrypted events at all. And then the browser like points to the proxy. So when you make requests, the proxy takes the hash value, looks it up, and then decrypts locally and sends it. So your information never actually has to leave your premises unencrypted.
Oh, okay, great. So, okay, but that's only my curiosity, but yeah, concern is resolved. Thank you. Okay, yeah. Let's go further. So, like right now in the modern solutions, we have some senior people in this, like either software architects or staff engineers or principals engineers and so on. So my question is like, what those people should definitely know about observability nowadays to build efficient, reliable, resilient solutions?
Unfortunately, the thing that they most need to know is that everybody now uses the term observability, and you really need to be very careful about what you buy, because it's just slapped on the side of everything now. I've written a lot about this. I think that, the world is getting so much more complicated that we need observability to mean something real, not just be like a catch-all term for everything that you can use to look at the system. So just be careful. What's on the sticker is not necessarily what you're going to get. You do need observability, but ask them hard questions. Do they handle high cardinality? Do they handle high dimensionality? Is it all connected, or are they paying to store the data once for metrics, once for logs, once for like, those are the questions you need to ask in order to unearth whether or not what you're getting is what you really need.
Okay. Next question is like, right now, like we're facing a problem. For example, so right now we're storing our logs for the request for like 2 weeks because it should be sufficient. However, due to different requirements, legal included, for some events we should store the logs for like, I don't know, 2 years, because like the customer can return, can ask for the refund, can ask for, I don't know, their data and so on. So I lost you for a second. Okay.
Back. The last thing I heard was can ask for a refund.
Yeah. So ask for the data and so on. So how those problems are typically resolved? Like, do you just store all the data for 2 years, or there are some some modern solutions to the problem?
Yeah, in general, I think logs should die in a fire. They're just they're just, unstructured logs are just like spammy strings, like they don't need to exist anymore. But for this purpose, I mean, I guess I would just say this has nothing to do with observability. It has everything to do with legal requirements. So take the smallest subset of logs you do need to keep. Zip them and put them in Glacier or something cheap, someplace cheap, because the number of times you're going to need to retrieve them are likely to be very few, but when you do, they're going to be very important. So you don't need to put a lot of effort into making a really fast, complex system that will retrieve them quickly for you. Just put them out to pasture.
Okay. Thanks. But let's get back to this very interesting statement about like logs should die in fire. But what should be instead of the logs? Like what should we use to?
So like when the reason I hate logs is because all of the assumptions that people have about logs are like, unstructured, and they're just kind of like fired off willy-nilly as the software is executing. Those are just bad. They're just bad. Now, you do need that data, but you should be bundling up into one arbitrarily wide structured data blob per request per service, and just like, collapsing all of the log lines that you would have emitted, because like while the code is executing, you might fire off 5 log lines for that one request, or 200, or 1, or whatever, and like that's so it's wasteful, and it makes it really, really hard to ask questions of it afterwards, because if you're grepping for this thing and it comes back 500 times, well, that doesn't necessarily mean 500 requests, because it might be emitting multiple times per so like it's so much easier to analyze and get useful things out of your data if you do this small amount of work to like collapse it into one. And I've heard this called canonical log lines. I love canonical log lines. So like use those. Unstructured data is going the way of the dodo bird. Like it's fine for debugging on the command line, but that is not how you debug or understand a modern software stack.
Okay. Can you please explain what do you mean by canonical log lines?
A canonical log line is another term to describe exactly what I've been talking about. An arbitrarily wide structured data blob with lots of key value pairs, one per request per service, that has all of the data that you might have wanted to log out during the execution of that request.
So it should like include like timestamp, service name, tag, like I don't know, stack
Process
trace,
ID,
request
ID, span ID, yeah, all that stuff.
The request itself, the response itself, right? So everything. So
everything.
Okay. So you're saying like instead of developers writing just the lines about like console log, blah, 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 this happened, that like this should be removed completely, but we should have the instrumentation that will gather all the necessary context in this structured blob, save it for the future, and that's it. So it means that it also removes the burden of thinking on behalf of the developers, like how verbose my logs should be. It's just like automated. Like
log verbosity is a plague.
Okay.
It's expensive. It's terrible. Yeah. No, I mean the data that you were going to put in console.log, absolutely keep it. And this doesn't have to be any harder, right? You write a language, a wrapper or a library or something. So it's the exact same amount of work, only instead of print to console, you're just printing to the event. You're just stashing it in the blob.
Okay. What should also go away from the, from very widespread practices that we're using nowadays in favor of the proper observability?
Well, I think the instrumentation part is, super key. Moving from unstructured logs to like, canonical logs, adopting open telemetry. OTel is now the second largest and most active CNCF project, only second to Kubernetes, by the way. It is the real deal. After years of false starts, open telemetry, or open tracing, everything like this is really happening. Other things, I think people really need to start getting used to traces. And I understand that like the previous generations of tracing tools have been incredibly opaque. They've been disassociated from the other telemetry. They've been very standalone and off-putting, but tracing is improving, and it's absolutely, it's a power tool moving forward. You really need it. I also think that honestly, most of these things, most of the rest of the stuff, obviously you need to adopt a tool that handles high cardinality, high dimensionality, you need your instrumentation order. The other things that I think that are really necessary though are more socio-technical practices. Things like making it super clear that your job is not done until you've watched your code run in production. That your job is to instrument your code as you go, like as you're making changes. In the same way you think about updating documentation, or the same way that you think about, adding debug output, you should be thinking about, how am I going to understand if this code I'm writing is working? How am I going to know when it breaks? This is not if it breaks, right? It's when it breaks. How am I going to know when this is no longer doing what I expect it to do? And then you go look in production, you close that loop. The cost of finding and fixing bugs goes up exponentially from the moment that you write them, right? You type, you backspace, that's the fastest you can do it, right? Second fastest is catching with your tests. The third fastest is right after you deploy, when you still have all that context in your head, you know what you built, you know why you built it, you know what you tried, you know it didn't work, you know the variable names, you know everything. You're never going to get that back. You need to look at it in production through the lens of your instrumentation and see, is it doing what I expect it to do? And fix it. And otherwise, like, it's just going to go out into the world. It's going to become part of the new normal. Your users are eventually going to find it and start reporting it. And then some other poor sucker is going to pick it out of the Jira task list and going to have to try and retrace your steps from the beginning. And that is so, this is a sort of compounding cost that ends up dragging an engineering team down so they can't make any progress, because they spend all their time fixing these incredibly costly bugs when they could have caught them at the source.
Okay, I actually can't help thinking about how it all connects so well with all the other things that we kept thinking and doing for the last, 15 years. So, for example, DevOps things. So we need to be able to put the things in a very small portions really fast to the production and be able to turn it off if it's goes wrong. Or we should be able to, to enable the functionality for the 3% of our users, because we want to try out our things. And this is what you're talking about, go into production. Or this connects very well with the agile practices that we need to go fast and, iterate every day. And, we need to complete the user story once we saw that in production. And we're not done until the story is completed and verified with our users. And only then we can say, okay, that works. Okay, let's go, and not coming back to that.
Together. It all fits together. And each place that you make progress contributes to the flywheel of the whole, right? This isn't something you have to solve all in one blow to start getting the benefits. You could chip away at it. You make your deploys a little bit faster. You make your diffs a little bit smaller. You make your observability a little bit better. All of this stuff compounds just the same way that the costs compound, the savings compound too. I think you're absolutely right. And I think that observability has been kind of one of the missing pieces. We have all these aspirations about making sure it works in production before we move on, about testing in production, about progressive deployments. But if you can't actually see what you're doing, it's hard to verify. It's hard to say, and be confident that, yes, it is working. And if all you have is metrics and dashboards, you can't actually. You can only take a best guess. You can't actually see exactly which requests are failing and why. So I think that this is kind of a missing link for a lot of teams who have maybe tried to get this and have found it really frustrating.
Yeah, I agree, because our current developer experience at Bolt is we put something to production that happens really fast, but then we have, Kibana logs. And then separately we have, Grafana dashboards. Yeah. And separately we have the database where we can take a look and see if the records are moving in the right direction. And it's all so disconnected. And you need to spend several hours to say, oh, okay, looks like maybe it is doing what I thought it will be doing. So
yes, exactly. That's what observability can solve. It can be as simple as just we use a thing called bubble up. That's literally if there's a dashboard or a spike, that you just draw a little bubble around it, and it immediately shows you all the ways that what you care about is different from everything else you don't care about.
Yeah, that's great. Let's talk about the next thing. So in the classic monitoring, what you do, you assign a threshold to some metrics, I don't know, CPU usage or memory usage or request time, execution time, and so on. And if it passes the threshold, you get an alert and you need to look at it. So how this, this alerting should work in a proper way with the proper observability applied?
Yeah, that's a great question. Basically, when systems become complex enough that you really need observability, you're also probably paging yourself like constantly, and a lot of false positives and all. And it's so frustrating, and it's so time consuming, and it just deadens the soul. You should move to SLOs. We find that people can delete 90% of their paging alerts if they move to SLOs. SLO, service level objectives, are what connect your experience, the developer experience, with your user's experience. And all you're saying is, here's the contract that we're making with our users, that the experience will be this good, right? Here's the budget. And then you alert someone if the user experience is impacted by, that percentage or whatever. And what that means is that anything else that breaks during the night that doesn't rise to the threshold of impacting your user, it can wait, right? And like you have two tracks, right? There's the stuff that you wake up and you're like, oh, these things happened overnight, I will go fix them, right? But most things don't need to be waking you up, right? You only need to get woken up if your users are in pain.
Yeah, so basically we're saying that we move our focus from highly technical things that do not relate necessarily to the user experience, but we're thinking about the user in the first place, and we're saying, okay, people are really waiting for, I don't know, the book description to load. And we say, okay, this requires attention, so let's improve it. And we're basically thinking from the user perspective to formulate our SLOs, so like objectives that we, trying to achieve with our services.
Exactly. You exactly got it. And no one should ever get paged about CPU spiking again. It is the most useless, noisy, ridiculous thing to ask someone to care about. And I understand if you've got nothing else, maybe that's better than nothing. I'm not convinced that it is, but it's so useless. No, care about what your user care about. And there are gonna be different things, right? Like for Honeycomb, it's like there are lots of things, like for example, the instrumentation, it can retry. Like if the ingest, is if it needs to retry a few times, like that's fine. Reads, we've set an SLO for reads, we set an SLO for writes. It's super important that data gets written. It's okay if a query times out now and then, right? It's important to have a budget, because that's how you can negotiate. And I think of it as like SLOs are like the API for your engineering teams. It's how, below the fold, you can decide what to work on as long as you're meeting your contractual obligations to your other teams. A lot of teams really struggle with, how do we know when to work on reliability? How do we know when to work on, our infrastructure or the tools, that we use? And how do we know when to work on features? And well, SLOs are the answer. When, otherwise you're just like running around whenever somebody complains. You're like, you're being really reactive, and you're running to fix things because people complain. You can't have a complaint-based routing system that is how you decide what to do, right? You need to prioritize based on your user's experience.
Okay, cool. That's really insightful. So I think I learned about observability like more than I read for like half a year in this half an hour. Yeah, so yeah, thank you very much. Okay, so I think I have the last question. I hope we can make it useful. So what is the biggest insight you got during your career, like regarding observability?
What is the biggest insight? I don't know. We kind of popularized the term. So I spent a long time just trying to figure out, because I'd had this experience at Facebook that was different from monitoring, and I spent 2 years really just trying to tease out all of the things that now sound so obvious. They were not obvious at all, to me at least. But I think that I guess the biggest insight that I had was just the limitations of metrics, just that's this thing that the entire edifice of the last 20 or 30 years of tooling has been built on, has really, I think, reached kind of the end of the road. Like, we've done all that we can do with that data type. And I completely understand why we did what we did, because for so long, hardware was so expensive. You had to capture the least possible amount of data that you could make valuable. But now, RAM is so cheap, fast disks are so cheap. We can be a lot more wasteful, which means that we can get a lot more wisdom out of our systems.
Okay, so basically the technological progress and the price going down for the data storage basically enabled our vision into our systems and understanding of what's really happening.
Yeah, which makes sense, right? Like the technology comes along to the point where like suddenly things are way more chaotic and complicated and far-flung and dispersed and everything than ever before. And so it makes sense that the tooling would need a similar sort of revolution to catch up.
Okay, cool. Okay, and then really the last question. So what do you want to wish to our viewers in their professional life?
I think my wish for people is that they discover the joy of owning their code. I feel like we talk about this a lot of times. It's like, oh, it's a drag, you get paged, you get woken up, it's, oh, we're asking so much of people. But I actually feel like it's motivating, it's inspiring, it's exciting to work on things when you know that they matter, when you know that they have a real impact on people's lives. And that feedback loop of just, I built it, I made it work, I see it working for people, and when it breaks, I can fix it. Like it's so fundamental. It's why we became engineers, right? The curiosity and our desire to build things and make things better. And I feel like ownership is, when people get detached from the ownership of their code, they get bored. It's not inspiring. It becomes this very academic exercise. And I really feel like, the zest of life is unlocked by really having some skin in the game and really getting close to your users and figuring it out what it is that they need and giving it to them.
Great. That's very inspirational. So yeah, thank you very much for that, and I hope our viewers found it inspirational as well. Okay, thank you very much. I can't explain how I enjoyed this conversation because I did a lot.
Oh, and me too.
Yeah, I learned a lot today. So thank you very much. Thank you for your time. Yeah, have a nice Friday.
Yeah, you too. Bye.